Bestelmeyer and Abby Miller. We are with the Asombro Institute for Science Education, as I said, which is in Las Cruces, New Mexico. Asombro is the Spanish word for wonder, and that's what we hope to inspire in our students is wonder in the world around them, particularly the desert we live in. And we do that through science education. We work with the schools around here in classroom visits and field trips. But we also have a lot of curriculum online, much of which we'll be sharing with you today. We do a lot of teacher workshops, and a lot of what we'll be talking about today in the next workshops that are upcoming is translating scientific research for the classroom. We work with scientists to bring what they're working on to you as educators and to your students. And today we're partnered with the USDA Southwest Climate Hub, which is also based here in Las Cruces, but works all over the Southwest, has people working all across the Southwest and the Climate Hub states. And the Climate Hub is doing a lot to think about how does climate change impact what's going on right now in our world. And it's part of preparing for climate change. That includes educating future decision makers like all our students. So with the Climate Hub, Asombro has published 17 lessons on climate change. They're in 3 modules: the climate change of the water cycle, the effects of climate change on agricultural systems, and climate change and the carbon cycle. But there's more lessons coming soon, and we'll be giving you a snippet of a few of those today. And if you're joining us for more workshops this week and next, you'll see most of these 17. Each of the lessons has educator guides, slides, training videos, student handouts. They're designed to be flexible, whether you're a formal educator or an informal educator, and they don't have to be used in these modules. They can all be used standalone. You'll see a smattering of that today. So, to our agenda today, we'll have a guest speaker, Katie Steele, who is from the USDA Southwest Climate Hub, talking about communication and her work around climate change. And then I'll show you all the resources that we have available, and we'll be talking about 4 of these activities that we share online together. You'll be participating in some of them as if you were students, and we'll also give you context for how we use them and teach them. And then we'll wrap up and ask you what you thought, and we'll be done here by 5:30. But if you have any questions, we'd love to know. Feel free to let us know if you have questions in the chat. We'll be sending you links in the chat as we go today for ways for you to participate and things for you to look at. Let me pass it over to Steph Bestelmeyer.
All right, well, good afternoon. Thank you, Kelly. And I'd like to join Kelly in welcoming you all to our first climate change workshop of this summer. And I'm really delighted to have a chance to introduce Dr. Katie Steele as our expert scientist who's going to be giving us a brief overview of what she does and a little bit about climate change today. Dr. Steele is the Deputy Director and the coordinator of the USDA's Southwest Climate Hub, which is based here in southern New Mexico, but it actually covers multiple states. And in her role as Deputy Director, she really leads outreach efforts for a lot of different stakeholders, and she facilitates partnerships among widely disparate groups of individuals. And so really, to put it in a nutshell, what she does is she coordinates meaningful conversations about climate change. So there's really no better person to start off our climate change workshops than Dr. Steele. Katie received her PhD in the year 2000 from King's College at the University of London. She's an expert in environmental sensing and GIS applications, especially related to climate change. And so without further ado, I'd like to turn it over to Katie.
Thanks, Steph. And I'll just get my screen shared. There we go. Thank you for that wonderful introduction, Steph. I'll try and live up to it. So I've prepared a little presentation today about climate change conversations, and it's based on several sources and on communication tactics that myself and my boss, Emily, have developed over the years. So without further ado, because I don't have much time, one thing that comes up frequently for us, and I'm sure it does for you if you're interested in having these conversations, is how do we communicate effectively about a topic that is complicated, it can be confusing, it's uncertain. Often we have to try and remember a lot of facts if we want to get our point across, especially with someone who doesn't believe in climate change. And then there's this political loading and climate change. But when we break it down, most conversations about climate change are either about climate change beliefs. Do you believe in climate change? If not, why not? Or what can we do about climate change? And there's commonalities in how we approach both subjects. So first of all, and this is probably key to what you all do as well, given that you're educators, is we must know our audience. Everybody's got a certain way in how they think about the world, and we call this their mental model. And most people's mental models are built up over time based on their available facts that they've had made available to them, on their past experiences, perhaps what their family thinks too. And also there's this intuitive sense that we all have. And people always use their mental models to help them interpret new information. And often climate information is new information to many folks. But whether you're speaking to a single person or a group of people, it really helps if you communicate by understanding the mental models first and foremost. And woven into this idea are some resources from Yale. Yale University has got a massive climate change communication program, and we draw on their expertise a lot. When we're thinking about talking about climate change, and especially here in the Hub where we've got a full range of folks that we talk to, from people who are very active and very believe in climate change to those who are very dismissive. But Yale's Six Americas basically divides up the full audience of people that you might talk to into these 6 groups. And it considers that people are different and they have different psychological, cultural, and political reasons for thinking the way they do and acting the way they do, and whether or not they act to prevent climate change in their own small way, or they just don't do anything. So first of all, ask, who are you talking to? Alarmed people, they know that global warming is happening, they know that global warming is caused by humans, and they support climate change policies. But often you'll find they don't really know what they can do or what other people can do to solve the problem, and that can be a bit overwhelming, even if you are very engaged like the alarmed folks are. Second, here we've got concerned people. They know global warming is happening and it's a serious threat, and they also support climate change policies, but they also believe that the impacts are perhaps a little ways off still, and for them it's not as high a priority as perhaps other things. Then we have the cautious. These folks are not really very sure yet. They haven't made up their minds. Is climate change really happening? Is it human caused? Is it serious? When you think about these first 3 groups that I've just introduced from the 6 Americas, these are the kinds of people that it's most useful to have these startup conversations with, because about climate change beliefs, and also get some practice in if you're not necessarily experienced at communicating in climate change. After cautious, we see the disengaged. These folks don't know much about global warming or climate change. It's probably not on their TV channel where they get most of their news. It's really not on their radar. Then we have the doubtful. They don't think that climate change or global warming is happening. And if it is, well, it's just part of a natural cycle. These things come and go. Finally, there's the dismissive. Global warming isn't happening. If it was, it's not human caused. And there's all kinds of conspiracy theories that are trying to persuade them to believe in global warming. It's just a hoax, along with Pizzagate and everything else. So we've got these 6 Americas what we're seeing most recently is this increase in belief in global warming. These proportions between alarmed, concerned, cautious, etc., compared to disengaged, doubtful, and dismissive have changed a lot over the last 5 years. And we're seeing more and more people entering these first three groups. And these first three groups are the most concerned, of course, and they're the most motivated to do something. They don't necessarily always do something. And that's where the second part of the conversation comes in. How can we persuade people to behave more sustainably? So talking to one of these groups, I just threw this slide in here just to give you this. Well, this is kind of self-explanatory, it's obvious. The degree of difficulty of a conversation about climate change is going to increase as you go from left, alarmed, to right, dismissive. So definitely, if you're new to talking about climate change with folks, try and assess who you're talking to and practice on these first three: alarmed, concerned, and cautious. Another thing you need to do is get your audience's attention. You can, and scientists are particularly bad at this, and I must say I started off this way, just thinking, okay, let's throw some information at people, that's all they want, then they'll learn and then they'll do something. It doesn't happen that way. You really need to frame the issue so it means something to them, and thoughtful framing will really help you get your point across. So to powerfully frame a message, what are the person's goals that you're talking to? What's your audience goal? Is their goal promotion or prevention? If you have a promotion orientation, think about using these words on the left of this table. If your audience has a prevention orientation, think about the right. So promotion is like, what do we want to achieve? What opportunities are there? What can we aspire to? Prevention, how can we prevent loss? How can we protect? How can we be vigilant against the impacts? The other thing to consider when we're framing is the local perspective. I'm sure you're all familiar with the polar bear example. This comes up over and over again in climate communication. If we're talking about the Southwest, and someone brought this up already, it's fire. If we're thinking about climate change in the Southwest, fire and drought and water, those are going to resonate with Southwestern audiences, amongst other things as well. So it's important to be familiar with the basic scientific data so you can then translate it into concrete experience. We can give the data, and as scientists, this is what we do. We hand over data. Here's some data. Now believe in climate change or do something about it. It doesn't work that way. And we had a hard time learning that at the Hub, since we're all scientists first and communicators second. So bear in mind that the human mind isn't designed to react immediately to threats, and especially if those threats seem to be in the distant future. Unfortunately, that's what scientists do. They say, look what it's going to be like in 2060 or 2100. So it's really important to combine the analytic processing system, the data science, with the experiential processing system. So this is two ways in which the brain processes information. Analytical is logical, deliberative, analytic. And reality is perceived in abstract symbols, words, numbers. We need to know about rules, we need to know about algorithms, and we show a lot of tables, figures, and graphs and charts. The experiential processing system, and I like this particularly because this really jives well with the data jams that the Asombro do. It's more holistic, intuitive, it depends on emotions, and it helps to communicate climate change or climate change action by using images and stories, by showing pictures, by, again, connecting to your local environment and making it an emotional experience. So appeal to both the analytic and the experiential processing systems. And again, I like what the Asombro do because that's what their lessons encourage students to do. Beware of the overuse of emotional appeals. Quite often when we believe in climate change, we get rather carried away and we say, if we don't do this by this and this and this, then everything's going to go to pot, and what's the point? If we get over emotional and if we get overly doom and gloom, then we really lose our audience and we certainly can impede their motivation to act on or to behave more sustainably. So what can we do about climate change? Well, everybody can do something, and I love the fact that everybody can do something is really appropriate for kids and changing habits to perhaps behave in a more sustainable way. But change is hard, and that change was never easy, and especially if you're trying to get others to change and not just change your own habits. But from the social and behavioral psychology fields, we know that it's much easier and much more successful to chip away on change in small bites. And I just want to drop a plug in here for a hackathon that I'm helping with in the fall with the Learning Games Lab here at New Mexico State University, which we're going to be working with 4-H agents and their young clientele on a food waste hackathon. And we wanted to focus on food waste because it's a nice small bite and it's something that kids can really get their teeth into and hopefully influence their families. So thinking about projects for kids of any age, or well, I say kids of any age, for you, for your students, for your family, for your community, think about when you're wanting to make a change that will influence climate change positively, pick a small subject like food waste or recycling properly, using less plastic, reducing water use, reducing energy, picking up litter. But this rewinds me back to motivating the audience and looking at their core values. So remember, your audience matters, what they think matters. If you're going to persuade someone to behave more sustainably, what's going to motivate the people who are alarmed or concerned are these climate change, ecology, recycling, environment-based messages. But that doesn't mean to say you can't get disengaged, doubtful, or dismissive people to act. You just need to have the right message. For those folks, say picking on something very particular, the energy crisis or fuel expense might be the motivating factor that gets them to behave more sustainably, even though they don't behave in climate change. And we have found that in certain audiences, don't even talk about climate change, talk about, say, energy freedom or water availability and so forth. So in conclusion, when you're talking about, or you're wanting to learn more about getting positive outcomes from climate change communications and motivating people to change, first of all, pick the right person. Don't start with the most difficult people. Don't start with the dismissive or the doubtful. Start with those moderate folks and learn from them and get practice in those conversations. And don't forget to listen to what they're telling you, and listen perhaps first and be patient. Be very aware that all of us tend to make assumptions about people, especially those who disagree with us. So it's always best to find out what you might have in common with someone else and then build out from there. Having a good basic of the understanding of the science is of course important, but you don't have to know everything. What is useful, and especially if you find yourself in a sticky spot, is always come back to the fact that the scientific consensus is that climate change is real, it's happening now, it's man-made, and it is a serious threat. But there is something we can do about it. Finish on a positive note. We can be hopeful, we can avoid doom and gloom, keeping that message positive, and then focusing on the benefits of taking action, and also that anybody can take action and then share that action with their friends, family, and community. So I'll finish there with any questions.
Thank you so much, Katie. We have time for one question. If anyone would like to put one in the chat, or feel free to unmute yourself and shout it out.
I'll have to open the chat here. There we go. I wanted to actually give a quick shout out from the person from California, and welcome. Southwest Hub covers Utah, Arizona, New Mexico, Nevada, and Hawaii, but our friends at the California Climate Hub cover California, and we work closely with them.
We're
I was just
happy to
curious
have-
as to what type of GIS mapping you do for climate change. That was sort of in your introductory or your bio.
Right, yes, and lots of that has been on the snowpack here in, well, northern New Mexico, southern Colorado. So it's been a mixture of remote sensing and GIS analysis, tracking the decline of the annual snowpack from around January 1st through July every year for a whole bunch of years, just to get an idea of how quickly it melts given different climate conditions, and then modeling future runoff.
Okay. I just found out that Albuquerque was not going to pull any more water from the Rio Grande this year. I was curious as to the snowpack. I guess that's snowpack affected, right, or influenced?
Yes. Yeah, the snowpack this year, it's been terrible. I mean, 2018 was really bad for snowpack in the Southern Rockies. And I think this year was on a par with that, not so much the quantity, but of the speed at which it melted out and didn't make it to the stream courses. So, yeah.
Awesome. Thank you for your presentation. It was very informative and very straightforward and understandable.
Thanks, Stephen. I appreciate that.
Thanks so much, Katie. And I just saw a question in the chat. We need to move on, but maybe you can address that question in the chat.
I will.
Or a comment there. Excellent. Well, let's see. We're going to move on and look at the Climate Hub activities that we'll be sharing. So there we go. So I mentioned earlier that Asombro has published 17 lessons. Our 18th will be going up very soon in 3 units or modules on the Climate Hub website. And we designed these to be conducted individually or as a unit, so they can be used in a classroom as a larger unit on the water cycle or agriculture and production or carbon cycle, or you're free to use them, pick and choose, use them kind of mix and match, because they are meant to stand alone as well. And we've provided educator guides, handouts, and slides. And if you would like to look at them right now, the link is in the chat. It's at asombro.org/climate, but I'll take you there and just show you what that website looks like. This is where you can access everything that we'll be doing today and more. So on this webpage, you have access to each of the units. I'll also mention the water cycle unit is available in Spanish as well. And then there's also YouTube videos for several of the lessons. These are instructional videos if you want the quick 5-minute version of how to teach it. And most or many of the 17 lessons have those. If you click Access the Curriculum, it'll take you to the Climate Hub website, and I thought I'd throw in the Climate Hub website has a ton of resources, not just for educators, but they put out resources for land managers and producers and ranchers, people in agriculture and forestry. And so there's tons of things on their website. If you're interested in snowpack and GIS modeling, you should definitely just Google Southwest Climate Hub and you'll come up with it. But here you have the resources for all the lessons, and they're broken into day 1, day 2, as if you were going to teach this as a unit. But you can find all the educator guides, the handouts, if there's board games, you can print in black and white and color, and everything you would need to teach these lessons you could find here on the website, which the easiest place to access it is from asombro.org/climate. So we're going to give you a taste of 4 of these lessons today, starting with this one, weather or climate. All of these 4 are about how do we talk, actually, sorry, I think we're covering 5 lessons today. All of these 4 are about how do we talk about climate and climate change and adapting or mitigating climate change. And then we'll be talking about some of the other lessons on data or big picture water cycle in other workshops that we hope you might join us for. So Abby's going to take it away, and you might want your phone handy if you've got it.
Alrighty, so thanks, Kelly. So hi everyone, my name is Abby, and we're going to start off our interactive lesson overview portion today with a lesson called Weather or Climate. So when we're having these conversations about climate change, it's really important that first we understand what we're actually talking about, right? The definitions of weather and climate are something that are really, really commonly confused. So it's a really good starting point to make sure that our students are able to talk about these terms and use the correct terms for what they're seeing. So when we think about weather, we think about short-term atmospheric conditions. So things like temperature, precipitation, humidity, wind, short-term things that are happening. And then climate describes the long-term pattern or the average weather in an area. So climate is talking about like a 20 to 30 year time period or longer. So those are the two definitions that this lesson really focuses on. So in this lesson, students are going to watch a short video overview of the definitions of the differences between those definitions. And then they're going to look at a series of images, and they're going to describe the images and what the image is describing. So they'll decide if each image represents weather or if it represents climate. So they're going to get to apply their knowledge of those two definitions. So we are going to practice this ourselves. We're going to kind of take on the role of being students, and we're going to play a fun little speed quiz using Kahoot. So if you've never used Kahoot before, it's a really cool interactive kind of like quiz tool that you can create quizzes for. You're going to need your phone or a different browser on your computer. And you're going to go to www.kahoot.it. And Steph has put the link in that chat for us. And when you get to the page, you'll enter the game PIN, which is 3079010. So I'll give everybody a minute to join up on here. So when we're playing this game, it's going to show you one of the images from the weather or climate lesson. And you're going to decide whether it's weather or climate. You get points for being correct, so make sure your answer is accurate, but you also get points for being the fastest. So hence the speed quiz name. And the winner of our speed quiz is going to win a prize today. We have kits for a different lesson that we're going to talk about a little bit later that we will mail to our winner. So whoever wins the quiz actually gets a prize today. Turn on the sound. All right. Does that look like about everybody joined? Anybody need another second to find it? All right, I'll give you another second. I know it's kind of hard to find at first. Alrighty, so let's go ahead and get started. So it comes up really fast, so make sure you're paying attention, thinking about the differences between weather and climate. Figure 1, forecaster in Flagstaff, Arizona. Is that going to be weather or climate? Awesome, weather, very nice. It's like almost everyone got that one. Very nice job. So our forecaster is showing the weather because they're talking about those short-term weather conditions. Awesome, nice job, Kirsten. Number 2, average daily temperature in the continental United States from 1961 to 1990. Awesome, climate. Everybody got that one super fast. Very nice. Ooh, Jennifer's moving up. Number 3, lowered reservoir levels during drought in Elephant Butte, New Mexico. That one's a little bit trickier. So that one is talking about climate because it was looking at photos from more than 20 years apart. So if you got climate, you got that one. Awesome, Jennifer's still in the lead. Figure 4, rain gauge in Fort Collins, Colorado. Awesome, weather, super fast, very nice. Jennifer still in the lead. Average annual precipitation in the continental United States from 1961 to 1990. Awesome, climate, very nice, everybody. And Jennifer still in the lead. Number 6, figure 6, snowstorm. Awesome, weather. Awesome, Kirsten moving on up, trying to kick Jennifer out of first place. Figure 7, average global surface temperatures. Awesome, climate. You guys did awesome with that. Let's see who our winner was. 3rd place, we got Albuquerque Mama. 2nd place, Kirsten. In 1st place, let me guess, must be Jennifer. Awesome, very nice. Great job, Jennifer. Kelly's gonna message you and figure out what address to send that kit you just won to. So that was a quick overview of what students would be doing in the weather or climate lesson. In that lesson, they would be looking at a worksheet or PowerPoint slides, but Kahoot is another really cool interactive tool that you can use to make these lessons a little bit more fun sometimes. So weather or climate. So understanding the difference is another lesson in the climate change and water cycle unit. And it pairs really, really nicely with the weather or climate lesson. So in this lesson, students are going to look at the media and think about if the American public tends to understand the difference between weather or climate, because we get a lot of our information about science topics from the media, right? So it's important that they are providing us with accurate information and that people in America are interpreting that correctly. So in that lesson, students are going to read a short article from NBC, and they're going to figure out if the American public understands the difference between weather or climate based on that. And they're going to look at these 2 images to think about that question. Right? So both of those lessons kind of gave us a brief overview, a big picture kind of overview of climate change, the differences between weather or climate, how we can sort of start talking about weather and climate is first we need to understand the definitions that we're talking about. So now we're going to take a step closer and we're going to look at one system that is specifically affected by climate change. And we're going to think about agricultural systems. So interacting adaptations is a lesson from the Climate Change and Agricultural Systems unit. And it's really cool because even if we're not directly involved in the agricultural industry, even though some of us may have students in rural areas that are involved in farming and ranching, if you're not involved in that industry, climate change is still affecting us, and it's affecting the agricultural systems as a whole. So climate change can affect food, fiber, and biofuel resources. It can affect environmental resources like soil and water. It can affect the economic viability of the agricultural industry as a whole. And it can affect the quality of life of our agricultural producers, like farm workers and people like that. So in this lesson, students are going to think about how adaptations to climate change that can be done on farms would interact with different components of the system. So to do this, they're gonna do some research about different adaptations to climate change. They're gonna make some posters, and they're gonna do a gallery walk to kind of look for patterns. So what are some of the impacts of climate change on agricultural systems? What pieces of the system is climate change expected to impact? So this lesson talks about 4 specific impacts, talks about changes in temperature, water supply, pests, and pollinators. So those are our 4 impacts of climate change. And then we want to think about what adaptations can address the impacts of climate change and how do they kind of go together. So I'm going to show you a couple of examples. Developing pest suppression technologies would be an adaptation that agricultural producers could use to combat changes in pests that may be affecting their crops. Providing nesting sites for native pollinators could help with changes in pollinator habitat, pollinator availability for their crops. Choosing appropriate flood tolerant or drought resistant crops could help farmers adapt to changes in water supply. And then if we looked at the use of solar panels as shade structures over crops, that could help farmers adapt to changes in temperature caused by climate change. So these are some of the adaptations, and you're going to get a chance to look at some of these a little bit closer in a minute. So now we have to think about who's going to be responsible for implementing these adaptations, like who's going to be in charge of doing it. So we're going to look at 3 different actors in the agricultural industry. So we've got producers or farmers, farm workers. We've got agro-industry or the business behind the farms. And we've got government. So these are our 3 actors in the agricultural industry, or who's going to be implementing those adaptations. So to kind of summarize all of that, this lesson really talks about how different parts of this system interact. So we've got these actors who are in charge of implementing different adaptations to help farms deal with the impacts of climate change. So you guys are going to get a chance to be students and start looking at some of these actors and impacts. So in a minute, you're going to get to go into breakout rooms, and you're going to be in groups of 4. And once you're in your breakout rooms, oops, sorry, close that. You're going to start doing the research section of this lesson. So you're going to find the breakout room, the folder that corresponds with your breakout room number. So if I was in breakout room number 1, I'm going to click the folder for breakout room number 1. And then you're going to go to the actors and impacts, Google Slides presentation. So it's going to be the first one that you're going to see in your folder. So everybody will have a copy of this in their folder. And the first thing you can do is zoom in because it's a little bit hard to read. So you can click zoom over here and zoom in, and you should be able to see this worksheet. So this worksheet is helping us think about the actors, the impacts, and the adaptations that are interacting within the agricultural industry. So you guys are going to be identifying, you're going to be looking at adaptations to climate change. You're going to be identifying what actor would be responsible for implementing that adaptation. And you're going to be looking at what climate change impact that adaptation would be addressing. So the first thing you'll do is you'll see these boxes over here. You'll read this adaptation right here. So this first one, and I'll do this first one as an example, it says develop pest suppression technologies. So can anybody tell me in the chat which actor would be responsible for implementing that adaptation? Would it be the producers? Would it be agro-industry, or would it be government to develop pest suppression technologies? Awesome, agro-industry, very nice, everybody. So you would type agro-industry there in that box. Because the industry is going to be responsible for those technologies, the behind the scenes kind of development of technology. And then you're going to decide what impact that adaptation is designed to mediate. So if we're looking at pest suppression technologies, that is going to impact pests. So you're going to drag one of these boxes over from the right-hand side to highlight that box in the color that corresponds with that impact. All right. And you'll see all these boxes on the right-hand side. They're in random order. So just drag the correct one over to your adaptation. And you'll notice that some of them have multiple colors on them, which means that that impact is, or that adaptation is affecting multiple impacts. All right. So we'll give you guys a couple of minutes in your breakout rooms to do as many of these as you can. If you just get through the first page, that's perfectly fine. The second page has a bunch more of these adaptations. And then the third page is a reference sheet. So if you're having trouble figuring out what actors and impacts go with each adaptation, you can look at this reference sheet and it gives you some more background information. That was a really quick overview of the research component of this lesson. So students are going to work through that worksheet, looking at those adaptations to climate change, thinking about what actors and what impacts can kind of go with each of those adaptations. So after they do that research, they're going to make some posters. So you're going to assign groups one actor and one impact to focus on. And you'll give each group a little card. So this poster is an example made using the agro-industry actor and the temperature impact. So groups will be assigned one actor and one impact combination. And they're going to need to make a poster about what adaptations could apply to that actor and impact combination. So they'll use that handout that you guys just started working on, the actors and impacts handout, to find adaptations that apply to those actors and impacts. And they're going to need to include at least 2 adaptations that can apply to that combination. So this is an example poster with agro-industry and temperature. And 2 of the adaptations that could apply to this combination were studying the use of solar panels as shade structures over crops and provide cooling such as shade structures or intercropping to sensitive crops. All right, so that's an example poster. And then once the posters are all complete, every group will have a different combination. They'll have different adaptations on their posters. You'll hang up the posters around the room and you'll do a gallery walk. So the groups will rotate around all the different posters and they're going to be given a pad of sticky notes that corresponds with the color of their impact that was assigned to them. And they're going to have to think about the question, could the adaptations listed on the poster affect your impact as well? So for example, if we were assigned water, we would put a blue sticky note on this poster if those adaptations could also affect water. And then you're going to think about if it would be a positive or negative effect. So you'll write a plus if there is if it's a positive effect, and a minus if it's a negative effect. So we could look at this first adaptation, solar panels as shade structures over crops, and we could say that more shade means that our plants don't need as much water. So that would be a positive impact on water availability for our crops. And so you would do that with all the different colors and all the different impacts. So it ends up that each poster has a bunch of different sticky notes with pluses or minuses on it. So the second part that you guys are going to do again in your breakout rooms, again really quickly, I'm so sorry about that, is you're going to do an example gallery walk. So you're going to go back to your Google folder, and we'll send that link is in the chat still. You're going to go back to the same breakout room, so back to the same folder, and you're going to click on interacting adaptations. So the second one that's in your folder. And to do a little virtual gallery walk, today we're going to use Jamboards, which is a really cool tool that we like to use. And this first slide gives us, this gives you all your instructions. So you're gonna rotate through the different Jamboards that each have a different poster on it. So first you're gonna assign each group member to one impact. So if you're temperature, you'll be yellow. If you're green, you'll be pests. If you're pollinators, you'll be pink. And if you're water, you'll be blue. So each group member will be assigned one impact. Then you'll use the arrows at the top right here to rotate through the poster. So you can do this all together as a group. And you'll see a different actor impact combination on here, and you'll see two different adaptations listed. So all you need to do is drag one of these sticky notes to the poster if it applies to your the impact that you were assigned by your group. So we'll give you guys 5 minutes to do this. Do as many as you can. If you only get through one poster, again, that's perfectly fine. We just want to kind of give you guys an overview of what this gallery walk looks like. So thank you guys for doing that quick version of interacting adaptations with us. So when students have done the gallery walk, they've looked at all the different posters around the room. They would know there would be a bunch of sticky notes on every single poster. So then students are going to think about, how do climate change adaptations affect other parts of agriculture? And how does the distribution of sticky notes show this? So they'll be able to look at all the sticky notes around the room and notice that everything in the agricultural system and climate change adaptations is all interconnected. And they'll sort of think about how the agricultural actors need to work together to adapt to climate change. And so that piece of the activity, there's not really a right or wrong answer with those pluses and minuses, positives and negatives on the sticky notes. It's really just to get them critically thinking about how those adaptations could affect the other parts of the system. So that lesson provides an overview of some of the ways that agricultural systems can adapt to climate change. And now I'm going to hand it over to Kelly, who's going to talk to us a little bit about mitigation. You're on mute, Kelly.
Always forget. So adaptation is adjusting our behaviors, our practices to live with climate change. And so that's an important part of the discussion around climate change. How do we adapt? It is really hot here in Las Cruces. How am I adapting? Not well. But the other part of climate change is mitigation, which is how do we reduce climate change and its impacts, whether that's less CO2 in the atmosphere, largely less CO2 in the atmosphere, but all the other things that go along with that. So this next lesson activity is about mitigation. It's called What's the Plan? It comes from our carbon cycle unit. And it started with this paper that came out in 2017. And it was a research journal article that looked at what are the most effective actions individuals can take to reduce carbon carbon in the atmosphere. And so they came up with these 11 actions that an individual could take, and they calculated how much doing each of these for 1 year, or doing these, how much carbon would be saved from the atmosphere in a year. And so these are some very drastic things and some not so drastic. Having one fewer child definitely saves a lot of carbon from the atmosphere when you think about the carbon footprint over a lifetime. Versus washing your clothes in cold water is a much smaller impact, but way easier to do. So this lesson gets at not just what can we do, but what should we do and how do we do it? And this is kind of a little bit of that hard conversation of like what makes sense. So Abby, if we can go to the next slide. So for this lesson, we take several of those actions and dig a little deeper and ask students to really tell us, do you think this is what we should be doing? Can you do this? Who should be doing this? How are we going to mitigate climate change? So we start with solar energy as an example that we can discuss together as a class or as a group. So in the lesson, you would have several slides to lead you through this discussion, or you can just kind of talk about some of the pros and cons. But what do we know about solar energy? It's a renewable electricity source. You need a bunch of solar panels. It would take 3 million solar panels to reduce carbon emissions by 0.5 petagrams per year. A petagram is 10 to the 15th grams. 1 petagram is equal to the weight of 6 million blue whales. So that's a big number, but that's the numbers that we have to talk about when we're thinking about reducing climate change, or mitigating climate change. So I see in the chat the question, isn't the standard parts per million? When we talk about it in the atmosphere, we talk about parts per million. When we talk about releasing carbon, we talk about amounts in grams or tons, or petagrams. So we have some challenges to solar energy. It's expensive. We got to find a place for them. They only work when the sun's out. People put them on their homes, but are there big solar farms? So what could make this happen? Just throwing out some ideas, you know, we need power companies to build big solar farms. Maybe I think California has laws requiring new homes to have renewable energy sources like solar panels. Tax breaks from the government, that's incentive to do these things. So Abby, if we can go to the next slide. So after just introducing some of those, you know, what are the challenges, what might help, we talk through these questions with students. And I'm not going to talk through these with you right now, but just some things to think about is, you know, what's the biggest challenges? We talk about who's responsible for this transition if we're going to transition, who's going to pay for it, who's going to benefit, and who's going to be hurt. And that can lead to, you know, your students might say, well, everyone's going to benefit from it because it's going to mitigate climate change. Absolutely. And some people are going to benefit more than others, right? So it opens up kind of space for these conversations, and often students will bring this up themselves. And who's going to be hurt by it? Who's, you know, where is this going to go? Is it going to, are jobs going to be lost, and where are they going to be lost, or things like that? So talk through all these questions, and then next slide. You kind of put it all together in this, what we call a mini poster. So this is a poster, an 11 by 17 piece of paper, or two papers you can tape together to make a big one. And it's got questions for the students to fill out, or in this case, you, about who's going to be involved. Where's this going to happen? What are the biggest challenges, and how are we going to address them? Let's list the pros, let's list the cons, and then let's come up with, if I said you're in charge of making this happen, you now have to come up with a plan. How are you going to address your challenges? How are you going to address your cons? Do you have enough pros to outweigh your cons? Things like that. And next slide, Abby. And we have 5 of the strategies from that first infographic I showed you. and they're living car-free, using hybrid or electric vehicles, not eating meat, not flying internationally, not having one fewer child. So some things that are easy for some people and terribly hard for others. And we want students to think about them. And so I'm gonna ask you guys now to go into breakout rooms, and I'm gonna give you about 8 or 9 minutes to, you'll see there's a mitigation strategy page you'll be in the same Google folder. There's a mitigation strategy page, so you'll have one of these pages to look at. And then you'll have this poster to fill out as a group. So think about what strategies what could you do to implement this strategy, or would you implement this strategy? If we have time, we'll hear 1 or 2 groups at the end, but we might run out for that. All right, welcome back, everybody. I hope that was, I know, short, and I hope you had a good time with your group discussing. As we said, we want to give you a little taste, intrigue you, give you something to think about so that you remember these lessons when, you get to August and you're back with students. And you're making plans. So I want to give a quick reminder that several of these lessons have a video for you as an educator to watch and give you the instructions visually. If you're a visual person, it is all written out. If you're a reader, it is step-by-step, everything you need there also online. But for like interacting adaptations where there was a lot going on and you were going back and forth between the rooms, that video is really helpful for me. I had to watch it before today. I know a few of us did. I'm gonna pass it over to Steph though now.
All right. Well, thank you, Kelly. The final activity that we want to introduce you to, and we're going to give you just the less than 5-minute version of this, is an excellent one to really end this workshop, because it's really about how do you communicate climate data to non-scientists, and how do you start those really interesting conversations about climate. And this is, we didn't know Katie was going to mention this in her intro, but this is one of the activities that Katie was mentioning at the start, and it's called the Climate Data Jam. Next slide, please, Kelly. The Climate Data Jam is actually based on a model of the Data Jam that we actually established here at Asombro 10 years ago and have been using in a lot of different contexts. The heart of a data jam is really 3 things. We give students real, authentic data and ask them to pick out a data trend by interpreting that data in some way. Then they make a creative representation of a data trend that they see in the data that they're given, and they present their project. So here's a couple of examples of creative representation. So on the top there, this is a ballet dancer who actually represented precipitation data by using the height of her leg in an arabesque, and that was scaled to the amount of precipitation we received that year. In the bottom left there, this was on Halloween. So these girls were dressed up. They had actually made a musical composition where high notes represented high temperatures in various seasons and lower notes represented lower temperatures. And in the bottom right there, this is an example using a data set with kangaroo rat populations, obviously not from our climate data jam, but these students made piñatas shaped roughly like kangaroo rats, and the circumference of the piñata was scaled to represent the number of kangaroo rats in the population this year. So we really give students lots of leeway to really bring their own creativity, their own interests outside of school to bear on the Climate Data Jam project. Next slide. The data for the Climate Data Jam is really an amazing tool that's been developed by the Southwest Climate Hub, and it's an interactive county level temperature and precipitation set of maps. And these, what students do is they go to their county, and it's in the entire continental United States. They click on their county. So over on the left, that's a map of New Mexico showing Guadalupe County. And then over on the right, that's the precipitation map for here in Doña Ana County. And when you click on any of these counties, you'll get a table like the one shown there on the right. If you focus in on that precipitation one, that's probably easier to see. The data is broken up into current, which is from the Prison Climate Group. This is 30-year average, in this case, precipitation in our county, both annually and then broken out by season. And then the future data is a series of 20 general circulation models downscaled to the county level. And the years for this is 2040 to 2069. So if you think of a 13-year-old that might be in one of your classes, they're going to be in their 30s, 40s, and 50s. So this is very relevant future precipitation for them. So students will take a look at their county's data on either maximum temperature and also precipitation, and then they will get a chance to make a creative way to represent one trend that they see in the data. And yes, the precipitation is in millimeters. Thanks for that reminder. And the temperature is in Celsius. And there's a suggestion for if you would like your students to convert to Fahrenheit, you can see how to do that. One source to do that in the teacher guide. And the next slide, Kelly. So we suggest doing this over the course of 4 days. There's a lot of flexibility in how you do this, but we have done this in 4 days. In the first class period, we give an introduction to the project and have students access the data and start thinking about their projects. Then we give them 2 class periods to prepare their projects. You can certainly give them more time if you would like, or you can give them a shorter amount of time if you want them to do a simpler creative project like an acrostic poem, for example, or a skit. And then on the 4th day, we highly recommend that you have them do their presentations for each other. There are some amazing conversations that come out when students do these presentations to each other and kind of talk about the different trends that they've seen in the data. This is the 5-minute version of this lesson we're showing you today, but on Wednesday, you're going to actually get a chance to dive into those data a little bit yourselves and have a little bit of the fun of doing a data jam. So if you want to join us for Wednesday's workshop, you'll get a little better taste of that because it relates to meaningful conversations, our topic for today, but also certainly using data to understand climate change. And with that, I will toss it back over to Kelly.
All right, thanks, Steph. Well, that is all we are going to try to pack into today. I know that was a lot, and there's plenty more. We have 3 more workshops where we'll cover many more of these. And then we have more lessons in development. Where's Our Water? Water Conservation in the Southwest is a lesson we developed this year for doing remotely. It's a couple of videos with worksheets and activities that students could either do at home, really hands-on kind of engineering and design, or you could definitely do it in the classroom. And that one is going up online as soon as we talk to our web person. So we'll get that up in the next couple of weeks. Last summer, we created a climate change and wildfire unit, and we've just been waiting to get into classrooms to pilot test it. It's really geared towards high schoolers, but you could probably definitely use it with middle. So we're hoping that'll go up by the end of the year. And then Water Conservation Data Jam is a big data jam project all about water conservation. And that'll be up probably by the end of the year or early 2022 also. So there's lots more to do. You got a quick look at a few of them. Just a little plug for what we do here at Asombro. We do classroom visits, we do field trips, but over this last year, we've developed a lot of things that you could do in class or online, videos for grades 2 through 12. They could be, things students can do as homework, things they can do in virtual learning if you are doing virtual or remote still. We have lots of kits and hands-on stuff that we can provide to you. And it's all next gen science standards and Common Core science aligned. So feel free to get in touch with us and we would be happy to share this with you. You can look on our website, asombro.org. So last things, please, if you would take a moment to fill out our evaluation form, which I believe is, the link is in the chat. Really appreciate any feedback you have. I am going to, don't go anywhere because we have some kits to share with all the supplies you need for interacting adaptations and doing that lesson with students. And I'm gonna hand those out in just a minute with my wheel of names. If you win, we wanna give you one. And then we have many upcoming workshops. We will send out the PowerPoints. I assuming you're asking PowerPoints, let's see, for all lessons are virtual deliver. Oh yeah, everything is available online. PowerPoints and Google Forms for lessons are available online. If you would like the PowerPoints from today, please send me an email, or if you'd like a certificate to show you participated today to receive credit, please send me an email or a chat right now, and we'll make sure you get that.